Today we're going to be starting chapter 12. We're going to be doing some notes on chapter 12, 12-1, and we're going to be doing problems 12-1 to 12-6 from our book, but on the attached Google Doc that I sent you guys in Google Classroom. So let's start with our notes. So we're going to open our composition book up. And let's write our table of contents. So this is chapter 12. And chapter 12 is Counting and Closure. That's the title. So chapter 12, Counting and Closure. So again, chapter 12, Counting and Closure. And in this chapter, we're going to be learning 3 ideas: fundamental counting principle, permutations, and combinations. Today, we're going to be focusing on the first one, fundamental counting principle. Fundamental counting principle. And then I'm going to change my page and I'm going to write fundamental counting principle, and we're going to talk about that. So fundamental counting principle. And so the fundamental counting principle states the following: if one event occurs m ways and another event occurs n ways, then together the events can occur m times n ways. Then together the events can occur m times n ways. And I'm going to put here, assuming the second event is not influenced by the first. Assuming the second event is not influenced by the first. And if it is influenced by the first, then instead of this being n ways, this number might change. And we'll see that in some of our examples. Our first example, let's say you have 10 shirts, 7 pants, and 2 jackets. And we want to figure out how many different outfits you can make. So you have 10 shirts, 7 pants, and 2 jackets. And we want to know how many different outfits can we make. So in order to do this, what we're going to do is we're going to do something called a decision chart. And we have 3 different items we're going to be making decisions on. So the first one we're going to do is shirts, then pants, and then jackets. And so what we're going to look at is how many different choices do we have for each of these. So for our shirts, we have 10 different choices. So we're going to go 10 times. For our pants, we have 7 different pants. So we're going to times it by 7 times. And then for our jackets, we have 2 jackets. So we're going to go times 2. And if we multiply 10 times 7 times 2 together, that's going to give us our outcomes, which is 140 different outfits. And for this, we're assuming either everything matches or we don't care whether or not it matches. So we have 10 different choices here, 7 different choices here, 2 different choices here, and we multiply those 3 things together. So we're going to be going back and forth between doing some notes in our composition book and working on 12-1 to 12-6 together. So right now I'm going to be looking at that worksheet. So if you want to get that worksheet out, I'm actually going to put it on my phone to show you guys that you guys can actually edit through Google Classroom on your phone, or maybe if you have a tablet. So let me get mine up here. So I signed it to myself here. So I'm going to click on it and I'm going to come down here, and here's my PDF that I can work with. And there's the worksheet, 12-1 to 12-6. And you'll notice that up here, we got the little pencil. That's where you can edit. So I'm going to click that, and now I can edit it. I'm going to turn it sideways so I can see it a little bigger. So let me do this first one on the phone just to kind of demonstrate that you guys can do this. And you guys can even submit it to me from your phone by writing on it. So 12-1, Nick's new phone is prompting him to choose a 4-digit, let me just zoom in a little bit more, a 4-digit passcode. On the screen, it says choose any digit 1 through 7. After typing in the first digit, the flashing dash prompts him for the second. As he thinks about his second choice, he wonders how many different passcodes are possible. I need a decision chart. He writes the following diagram on his paper. So he has his first digit, his second digit, his third digit, and his fourth digit. And he's using the digits 1 through 7. 1 through 7 are the digits that he's using. Now, right now I'm using a stylus, but you can also use your finger to write. Both of them work. The stylus is a little easier, but I've been going both ways on some of these different worksheets. So let's try this problem. So we have the digits 1 through 7. So for the first one, he has 7 choices, the numbers 1 through 7. Now it doesn't say he can't repeat. So we are going to assume that he can choose all 7 again for the second one, and again for the third one, and again for the fourth one. So we have 7 times 7 times 7 times 7, or 7 to the 4th. And if I put 7 to the 4th in my calculator, 7 raised to the 4th, I end up with 2,401. So I get 2,401 different passcodes. So now, the second question here was just asking for the final answer. So that answer again was 2,401. The next question says, what is the probability that Nick's randomly selected 4-digit passcode will be 2,763? So we had 2,401 different passcodes. This is 1 out of the 2,401. So our answer is going to be 1 over 2,401, and that would be our answer. So now I'm going to go through the second one with you, 12-2. I'm going to flip to my computer, so it might be a little easier for you guys to read, but I just wanted to show you guys that. And one other thing real quick. Up here, you click on this and you can save it. You want to save it, otherwise it's not going to be on your thing. And then you can directly send this to me after you're done with all of it. And you can send that in where it said turn in. Okay, so now let me change my screen so you guys can see the worksheet. Okay. So this was the first problem that we did. Let me move up here to the second problem. So now for the second problem, it says, how many 4-digit numbers or passcodes can you make using the digits 1 through 7 if you could not use any digit more than once? So it's basically like the last problem, we're doing 4 digits from 1 to 7, but this time we cannot repeat. So I am going to have 1, 2, 3, 4, and I'm going to have my first digit, my second digit, my third digit, and my fourth digit. Now for my first digit, again, we have the numbers 1 through 7. So I have 7 choices for the first one. Now the second one, once I've used a number, I cannot use it again. So the second one, I no longer have 7 numbers to pick from. I now only have 6. And then for the next time, now 2 numbers are gone. So now I only have 5. And then I only have 4. So again, each time I used a number, I could not use it again. So I was decreasing the amount each time. So I'm going to take 7 times 6 times 5 times 4. And when I work that out, I end up with 840 as my answer. Now, the next one, 12-3, I'm going to read through with you guys, but I am going to want you guys to try to set these up, and then we'll discuss them afterwards and see if you guys got the right answer. So on 12-3, use a decision chart to answer each question below. For A game contains 9 discs, each with one of the numbers 1, 2, 3, 4, 5, 6, 7, 8, or 9 on it. How many different 3-digit numbers can be formed by using any 3 discs? And just to make sure you guys understand, again, we have 1 disc with the number 1, 1 disc with the number 2. So we have 9 discs with the numbers 1 through 9 on them. And what we're trying to do is we're trying to pick from these and get how many different 3-digit number codes can we get by picking 1 disc, then another disc, then another disc. So try to set a decision chart for this and come up with your final answer. Okay, so for this one, you are going to have 3 different choices. So you're going to be picking your first, your second, and your third. So for my first one, I have 9 choices, the numbers 1 through 9. Now, once I pick that disc isn't available for me to pick anymore. So now when I go to pick my second number, I only have 8 discs left. And then when I go pick my third one, I only have 7 discs left. So I'm going to take 9 times 8 times 7, and I'm going to work that out, and that ends up being 504. So now we're going to do the same on letter B. Again, I'm going to read it and then you guys are going to try to set it up. So a new lotto game called Quick Spin has 3 wheels with the numbers 1, 2, 3, 4, 5, 6, 7, 8, and 9 equally spaced around the rim. Each wheel is spun once and the numbers the arrows point to are recorded in order. How many 3-digit numbers are possible? So in this case, we have one wheel with the numbers 1 through 9 on it, another wheel with the numbers 1 through 9 on it, and a third one. So again, each of these contain the numbers 1 through 9. And we're going to spin each of these once to come up with a 3-digit number. So you guys set up a decision chart and figure out the answer to this one. Okay, so for this one, again, it's like the one above. We have 3 different choices. The first spin, the second spin, and the third spin. So when we spin the first spinner, again, remember, we have the numbers 1 through 9 all on this. So I can get 9 different numbers. And then when I'm doing the second spin, the second spinner, it also has the numbers 1 through 9 on it. So I again have 9 different choices. And then when we do the third spinner, we have the numbers 1 through 9. So I have another one that has 9. So when we do this, we get 9 to the third, and that is 729. So on part C, it says, explain the similarities and the differences between parts A and B. So in both of these problems, we had 3 choices. So both had 3 choices, or 3 decisions we had to make. Let's put 3 choices to make. Both were using the digits 1 through 9. And the difference was the first one we were not allowed to repeat, and the second one we were allowed to have repeats. So first allowed repeats, or no, sorry, first had no repeats. So first had no repetition. The second one allowed repetition. Okay, so now 12-4, Marcos is selecting classes for next year. He plans to take English, physics, government, pre-calculus, Spanish, and journalism. His school has a 6-period day, so he will have one of these classes each period. So again, he has 6 periods in his day. He's going to take each of these classes in English, physics, government, pre-calculus, Spanish, and journalism. Part A, how many different schedules are possible? So in this case, if we're setting up a decision chart, we're going to have first period, second period, third period, fourth period, fifth period, and sixth period. So right now you guys fill that in. So in this situation, we cannot have repetition. He's not going to be taking 6 English classes or 6 physics classes. He's going to be taking one of each of these. So period 1, he's going to be doing He has 6 choices for period 1, but once that period is filled, he's not going to take that particular class again. So once he goes and chooses a class for period 2, he now only has 5 different choices. And then for period 3, he only has 4 choices. And 4th period, he'll only have 3 choices. 2nd period, he'll only have 2 choices. And let me go back and change that. Okay, so how many different schedules are possible? So he's going to have his first period, so period 1, period 1, period 2, period 3, period 4, period 5, period 6. So right now, you guys fill this decision chart out and figure out how many different schedules are possible. So for this, he is going to be taking 6 different classes. So for period 1, he has 6 different classes he could have period 1. Now, once that period 1 class is chosen, he only has 5 different classes left to pick from. So period 2, he'll have 5 choices. And then period 3, he'll only have 4. And then 3, and then 2, and then 1. So we're going to be multiplying out 6 times 5 times 4 times 3 times 2 times 1. And when we do work that out, that ends up being 720. He has 720 different choices for his schedule. How many schedules are possible if pre-calculus is period 1? So now when I'm doing this, I still have 6 periods. So period 1, period 2, period 3, period 4, 5, and 6. Now the difference is going to be that he wants to have pre-calc period 1. So here, period 1, he's going to have pre-calc. There's only one option for him for this. It's a different color. So he has one way that can happen. Now, for period 2, 1 class is gone. So out of the 6 classes originally, he only has 5 left, and then 4, and then 3, and then 2, and then 1. And when we multiply this out, we end up getting 120 choices. So then on part C, it says, what is the probability that Marcos will get a first period pre-calc? Why? So in terms of the probability, we know how many different ways he can get that. He can get it 120 different ways. And there are 720 different schedules. So his answer for this, the probability is going to be 120 different ways for him to get pre-calc period 1 out of 720 schedules. And that reduces down to 1/6 or 16.6 repeating %. So now let's take a look at D. What is the probability that Marcos will get both period 1 pre-calc and period 2 physics. So you guys try this. Again, remember, they're asking what is the probability? So first you're going to have to figure out how many different ways you can get first period and second period physics, and then you need to figure out the probability. Okay, so we have period 1, period 2, period 3, period 4, period 5, period 6. Now, period 1 is pre-calc. There's only one way for him to have pre-calc. Period 2 is physics. There's only one way for him to have physics. So now we have 2 classes that are gone out of our 6 total classes, which leaves us with 4, and then 3, and then 2, and then 1. And when I multiply all this together, I end up getting 24. So now, again, remember, it was a probability. So we have 24 different ways for that to happen out of 720 schedules. And when we reduce that, that actually reduces down to 1/30, which is about 3.3 repeating percent. So now on the next section, you're going to want to look for your calculator or have your phone calculator, but we're going to be looking for a button. And this button on your calculator is labeled n factorial. Just highlight it. N factorial might have an x factorial or a little exclamation mark. Let me show you guys on the graphing calculator. So let me just change the screen so that you guys can see the calculator. So this is the graphing calculator. So on the graphing calculator, a couple ways you can find it. One way is under math, and it's under probability. I usually go backwards, so I use the arrow backwards, and it's number 4 here. Another way to get to it is using the alpha button. So remember, alpha y equals fractions, and alpha window here gives us different choices. Okay, we've dealt with it for taking an nth root of something or xth root of something. Right here, number 9 is your factorial. So for example, if I wanted to do 10 factorial, I would go 10, and we say factorial, that's how we read it. And I could go alpha window, and I'm going to pick number 9. Let me just have it focus a little better. And I hit enter, and then that would be our answer. So what I'd like for you guys to do is on the worksheet, I would like for you guys to do this section and work out 8 factorial down to 1 factorial. Okay, so now let's look back at the worksheet and let's check your answers. So for 8 factorial, you should have had 40,320. Let me make that one. Okay, let me right now share with you my answers to see if you got the same. So you should have gotten 40,320 for 8 factorial, 5,040 for 7 factorial, 720 for 6 factorial, 120 for 5 factorial, 24 for 4 factorial, and 6 for 3 factorial, 2 for 2 factorial, and 1 for 1 factorial. Now it asks which results is the same as the number of Marcus's possible schedules. So remember, his possible schedules were 720. So he had 720 possible schedules. So down here, that one is going to be the same as this one right here, 6 factorial. So now they're asking us, what do you think 6 factorial means? Well, in our problem, we had 6 for the first period, 5 choices, 4 choices, 3 choices, 2 choices, 1 choice for all of his periods. So 6 times 5 times 4 times 3 times 2 times 1 is 720. And that is what 6 factorial is equal to. So let's switch real quick over to our composition book and let's add in factorial for that. So let me switch over the screens. Okay, so we're now going to add in factorials. So factorial. And factorial, n factorial is equal to n times the number in front of that, which is n minus 1, n minus 2, dot, 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 and keep going down until we get down to 3 times 2 times 1. So it's basically from whatever this number is, all the way down to 1 we're multiplying. So, for example, 5 factorial is equal to 5 times 4 times 3 times 2 times 1. So when we're trying to do these problems, it's a little easier for us to type in 5 factorial than have to type in 5 times 4 times 3 times 2 times 1. And in both cases, we're going to end up with 120 as our answer. Now, a little note, 0 factorial is equal to 1. So 0 factorial is equal to 1. So that's something that you want to understand. Okay. So now let's go back to our problems and let's use this information that we just learned. Okay, so let me get back to our problems. So let's take a look here on letter D. Explain why 4 factorial gives the correct solution to the possible numbers of ways that you can arrange the letters of M-A-T-H. So again, we have, if we're going to rearrange these letters, we have 4 letters, we have 4 slots. The first one, I can use any 4 of these, so I have 4. My next one, since I've used one of the letters, I only have 3. The next time I only have 2, and then 1. So instead of typing in 4 times 3 times 2 times 1, we could type in our calculator 4 factorial, and we're going to end up getting 24 as our answer. So the last question here, 12-6, says, remembering what n factorial means can help you to do some messy calculations quickly, as well as help you do problems that might be too large for your calculator's memory. For instance, if you wanted to calculate n factorial over 6 factorial, you could use the factorial function on your calculator to calculate 9 factorial, and then calculate 6 factorial, and then you can put 362,880 over 720 and get the 504. So you're saying you can do this separately. You could also put 9 factorial over 6 factorial in your calculator. But sometimes you can't use a calculator for things like this. It's nice to have another way of doing this. So if we take a look at this section here, let me just highlight it so you see exactly where I'm talking. So we're looking right here at this section. So I wrote out what 9 factorial is. 9 times 8, 7, 6, 5, 4, 3, 2, 1. I wrote out what 6 factorial is. 6, 5, 4, 3, 2, 1. Now, what happens is you actually have some of these numbers that are going to cancel out from top and bottom. So what's going to happen is this 6, 5, 4, 3, 2, 1 is going to cancel with this 6, 5, 4, 3, 2, 1. And I'm left with 9 times 8 times 7, or 504. Now, the way I write these out is, let me just write it out down here. I would write 9 factorial, not all the way down to 1. I would write 9 factorial, 9 times 8 times 7 times, and I would stop at 6 factorial because I know on bottom I have a 6 factorial. And 6 factorial is still 6, 5, 4, 3, 2, 1. But instead of writing it out, I know that this and this are going to cancel, and I get my 9 times 8 times 7. So what I'd like for you guys to do right now is try A through D using the same idea that I just showed here, and then we'll check our answers. So if we're checking our answers to these, you can see that I wrote out 10 times 9 times 8 factorial over 8 factorial here on the top one. So this 8 factorial and this 8 factorial are going to cancel out. On the next one, 70 times 69 times 68 factorial over 68 factorial, the 68 factorials are going to cancel out. On C, the 4 factorial is going to cancel out with the 4 factorial. And then what's going to happen is I do have this 3, 2, 1, which is a 6, so it can cancel out with this 6. On the bottom one, my 18 factorial is going to cancel out with my 18 factorial. And then my 2 times 1 can cancel out with part of this 20, leaving me with 10. So now when I do this math, on the top one, I have 10 times 9, which is 90. Here I have 70 times 69, And when I do 70 times 69, I end up with 4,830. On letter C, I'm left with the 7 and the 5, so I end up with a 35. And then on D, I'm left with the 10 and the 19. Everything else cancels out, and I get 190. So tonight for homework, you'll have a worksheet that's going to be having you guys practice doing this. And you guys can either print it out and write on it and take a picture and send it in. If you want to try doing it on your phones, I do want to see not just the answers, I do want to see what your decision chart was. Then you can give me your answer. And then you're going to be submitting those to me. Or if you're going to just do it on a separate sheet of paper, that's also acceptable. You can do that and submit that.